Hi everyone, and welcome back to this series of tutorials about using WEKA as our machine learning tool to assess different power system assets. So far, we only worked with ANN as the classifier, and today we'll try to use some other classifiers and see how good or bad their results will be compared to the ANN. So today we'll explore three other classifiers: support vector machine, or SVM for short, K nearest neighbor classifier, or KNN, and one of the decision tree based classifiers. When today we'll use the J48. The intention here is not to go deep into the math, but the intention, as I mentioned before, that the intention is just to understand in a very intuitive way how those classifiers work. So we'll start with the support vector machine, and let's say that we have a 2D problem. So meaning that we have two input uh, features, and we have two classes. And this class, we want to differentiate between these two classes. So what is a good way to do that? Now, when you look to those two classes, they are what we call linearly separable, meaning that a linear line can be drawn and separate these two classes from each other, as we can see here. So this linear line yx plus b equal to 0 could be our separate line between the two classes. And if the wx plus b greater than 0, so we are in this class, we call it plus 1. And if it is less than that, then it is minus 1, or this is the other class. So it looks very straightforward, very simple. However, there is one issue here, which is the following: that we don't have one unique line to distinguish between the two classes. There are infinite number of lines that we can come up with. So which one is better? That is the question. Especially now, if this line was drawing, we draw this line in the learning stage. Now in the testing stage, when we have a new data set comes, it might be misclassified. So how I can guarantee that this specific line is the best even for the testing? So to do that, instead of having one straight line, we will have a line with a margin around it. And the upper margin, which is this one, will be just touching the closest data points from this class. And the bottom margin will be touching the point, or the closest point from the other class. Okay, and in between here, all this is like a margin between the two classes, not just a line, but a margin. And we'll try to select the line that maximize this distance between the two classes. So when you look here, uh, this is our line. And if it's a 2D problem, it is a line. If it is multi-dimensional, then we call it becomes a hyperplane. Okay, so then I will have a margin. Okay, so this will be your support. This is what we call the support vector, which is the closest point that you have from this class perpendicular to the hyperplane, and this one is from the other class. Okay, so these are two vectors. This is why we call it support vector machine. Okay, now that is the general view of SVM. What if the two sets of data, they are not linearly separable? We cannot draw a line between them. Okay, then we use what we call the kernel trick. And the kernel, this is a huge topic by itself, but visually I will show you the following slide. Now, if this is my class, it's a 2D problem, and the classes here are somehow, they are not linear. So this is to draw a line. You can't draw a line here between them, or a hyperplane. So what we do, we take the input data to a different dimensions. So here we take it from 2D to 3D dimensions, and we do certain adjustment to the data, and then we came up with our decision surface between these two classes. So we can change a nonlinear problem using the kernel trick to a problem that we can actually assign a linear border between the classes. So this is, in a very simple language, the support vector machine. Let's talk about the KNN. The KNN basically is a very straightforward type of a classifier. So basically what it does, you have the two classes. No, we have two classes here. Let's say we have bad and good oil. Bad and good. Okay. So this is your bad sample and this is your good sample. So these are all good and the blue one are all bad samples. Excellent. Now I have a new sample that belong to the good and the bad. We measure the dimension between this new sample to the closest one from the good, closest one from the bad, and see it's closer to which one. So if we look here, this sample, this is the distance with the closest one, and this is the distance with the closest one from the bad class, and this is the closest one from the good class. And obviously, this green sample is closest to the good sample. Okay. Now, how we measure the distance? There are different formula. There is, for example, this is the most known one, the Euclidean distance, and there are some other formulas. And we'll see that when we apply the KNN in WEKA, that we have the option to select what distance to use. Okay. Now, this is called KNN-1, but you can have KNN dash 3. What does it mean? We will measure the distance between this sample and the closest 3 sample from each class. So I will measure from this sample for the good and from this sample and maybe this sample. And add all these, sum all these distances, and then I will do the same thing with the other class and compare. Okay, so when you increase the number of samples that you are comparing the distance with, the sample might go to the other class. Okay, and we'll see the impact of this. It's changing how many samples that you are comparing with. Finally, for a decision tree, basically we start with the logic, with a condition, and then we branch out. This is why it's called a tree. So for example here, we have a two-class problem, and it's a two-dimensional. Means we have two features, x1 and x2. So we start, is x1 greater than w10 or not? So if x1 is greater, if it is no, it's not, then all of it is the blue sample. If it is yes, it is more than that, then we will have another condition. Is it greater than W20 or not? If yes, so if it's greater, this is W20. So if it is more, so this is this class, it is more than W2 and it is more than W10. W20, sorry, W20 and W10. So we have this class. So if it's not, then it is the blue class. So here you can see that with using this decision tree sequence, we can separate between the classes. We can have multiple classes. So here we have 9 class problems. So we start with all the 9 classes, 1, 2, 3, 4, 5, 6, 7, 8, 9. And you start with a condition. And then you start to reduce the number of classes until you reach at one condition, one of those 9 classes. So can be used for many class problem. So this is in a nutshell the SVM, the KNN, and the decision tree based classifier. So what we'll be doing now, we will try to use the WEKA to classify uh, the same data set we used for the ANN. So let's go here and let's use, this is our WEKA start. We'll explore, open the file. So we will use the same data set, the one that is the original data set. So it is the okay. So we'll use the three class problem here. Okay, this is our original data set. So if you just try to remember this, we will have the imbalance problem. Let's see if we have like a magic classifier that can solve this problem for us. Okay, so we'll go to classify. Now we'll start with the SVM. Okay, so we'll choose the classifier. So if you go to functions, you will find the SMO. SMO, this is the SVM classifier. Start. Okay, so we have here 90.137 overall accuracy. And when you look to the confusion matrix, we have the same problem. For the marginal, only 24 cases were correctly classified, but we have 54 misclassified. And we look here to the true positive. Clearly for the first and the third class, we have high accuracy, but the middle one, it is very, very little. If you click here on the SMO, you can play with some parameters. So this is the kernel that I talked to you about. Uh, in many cases, but not always, the default is the best. The default that you have is the best, but sometimes no, you need to play with. So if you come here and let's select a different kernel, let's see what will happen here. Okay, so we have like a different kernel. Let's see what we get the result. So remember, this is 90%. Do the start. So it is 88%. It is less, and you see here even we are getting even much worse for the marginal. Okay, so it's good to go and try different combinations, but we don't have much access, and this is the limitation of WEKA. You don't have full access about the capability of the classifier, but you have a very fair, good idea. Okay, so now let's go for the KNN. So KNN is under lazy. Even the name, the class is called lazy, and it is the IBK. This is the one, the K nearest neighbor. So let's start. So we're getting 85.89%. It is worse than the other classifiers because we reached 90% even with the NN. So let's click here on the KNN and let's see here. So KNN 1 only. So let's change this to 3 and see what will happen. Okay, and let's start. So now this is improved, becomes 89%, and this class becomes 46.2%. Let's click here, let's make it 5. Let's see if there is any improvement. There's good improvement between 1 to 3. Usually 1 is act poorly, not good. Usually 3 or 5. These are the two numbers that we usually use. So this is 89.58 percent. Let's start and see. Okay, 90.1. So it is very similar to the previous one, but we have a better, I mean, worst in terms of the true positive for the band, better for the marginal. So this is for the KNN. Let's select another classifier. Now let's go for the trees. So here you see that these are like these big names. This is, for example, functions, lazy, rules, time series, and this is the trees. There are multiple trees. I will select the J48. You can select anyone, but this is just to show the idea. Start. We are getting 90.54%. Again, close to what we got. One thing here you can do for the tree, if you right click here, visualize the tree. You can see the tree we just talked about here. So when you click here, now we will see the the tree, how it look like, the one that is generated inside the J48. So this is the tree that we have. Let's fit the tree, fit to screen. So this is our tree. So it starts from the color. If it is more than one, less than one. Then acidity. If it is more than 0.028, less than 0.028 or equal. And then it starts to branch, to branch, to branch until we come up with the final with the final decision about the class. Okay, so this is like what we I mean, this is three different types of classifiers. And let's do one last thing. Let me share. I'd like to do one last thing here to compare all the results. So let me go out of this. Let me share my results that we have here. Okay, compare all of them. So this is the ANN. So we have here 91.5%. And this is the true positive that we are getting for each class. Now, this is the SVM. So pretty close. And we look here, this is better, but this is worst, way worse by 20%, the marginal, okay, than the ANN. We'll come here to the KNN. When you look here, the KNN compared to this, which is this is 90.137%. I'm just showing one result I got per classifier. I'm not showing all the results, just to compare, to make the following point. So what you can see here, this is the G48, again 90%. So all classifiers, the margin difference between them is really small, not big difference. Sometimes, in some cases, in some data sets, you might see bigger difference between the classifiers. You see one classifier act better than the other classifiers. Is there a rule of thumb to tell us which classifier to use? I wish there is, but there's none. This is why they said that machine learning is a mix between art and science. Okay, there is a science behind that. There is a lot of math behind that, but there is also an art point. You have to try. You have to try your data. Each data will behave differently with the different classifiers. Some data behave excellent with certain classifier. Use different data, then this classifier fail to produce good results. So I will stop here. Now, what is next? Let's try to now explore different problems. Okay, so far we only dealt with one data set. Starting from next presentation or next tutorial, we will deal with different data sets, a different problem, and then now we will be using those four classifiers as our main classifiers to compare between the results. Thank you for joining me. I'm looking forward to meeting you in the near future. Bye, everyone.